I'm going to be doing some of the problems from our review number 2 for our Unit 4 polynomial test with you. So first, I want to look at number 3. Number 3, the directions just say to factor. So I will not be solving this, I'm just factoring it. It is the difference of two cubes. 125x cubed is 5x being cubed, and 64 is 4y being cubed. 64y cubed is 4y cubed. And so when you're putting it into the formula for the difference or sum of two cubes, the first one is to write what you see. So I have my 5x minus 4y. So I write my two cubed roots and I write a minus sign because that's what I see. There's a minus in the binomial, so there's a minus in the binomial. There's only one minus sign in my formula. So if I've already used it here, that means in my trinomial, they'll both be a positive. When you're doing number 2, since there's a plus sign in your binomial, then the minus sign will be the first one in your trinomial. So now inside my trinomial, I square, multiply, square my two cubed roots. So here I'm going to square the 25x for 25x squared, and I'm going to multiply them for 20xy, and I'm not concerned at all with the negative in front of the 4y, because remember, the signs are taken care of in the formula. And then 4y squared is 16y squared. And that would be my problem in factored form. So let's take a look at number 4. This is to be a plus minus. So in this problem, you're asked to write a polynomial that could possibly have these roots. So things like the x equals 0 and x equals 3 are easier to find. In this case, I know if I subtract the 3 back over, that this is the factor x minus 3. And really, x equals 0 just gives me an x, because if I subtract 0 over, I just get x minus 0, which is x. And then lastly, this one, because of the plus minus, as in number 5, because of the plus minus, I'm going to have to reverse complete the square. So to do that, step 1 was to move any numbers that were in front of the plus minus. So I'm going to subtract the 2 over to move it, and I have a plus minus I then on the right. So now step 2 was to square both sides. So when I square my left side, I get x squared minus 4x plus 4 equals, and then I squared is just negative 1. So the last step was to set it equal to 0. So I'm going to add 1 over and get x squared minus 4x plus 5 equal to 0. This is the factor that gives me 2 plus or minus I as its root. So I have these 3 factors for my polynomial. So my polynomial would be x times x minus 3 times x squared minus 4x plus 5. This is my polynomial in factored form. If I wanted it in standard form, I would just have to multiply it all out. I would create a 3 by 2 box, and I would box this out, and then I would multiply every term by an x, and then I would have my polynomial. I'm not going to do problem 5 all the way, but I had a lot of students asking me about squaring the 2 rad 3. There's an example in your 4.1 notes, because this is section 4.1, that's almost identical to this. But step 1, when you're reverse completing the square, I'd get an x minus 3 on the left equals a plus minus 2 rad 3 on the right, and then I would square both sides. In squaring this term, I would square each part. So 2 squared is 4, and then square root of 3 squared is 3. And so then I would get a 12 when I square that. And you would keep working the rest of the problem. So let's take a look at page 2. Page 2 had a lot of problems on it, and the directions were to solve. So for page 2, you're going to solve these to find the roots. And if they're factorable, we'll factor them. And if they're not factorable, then we'll use our rational root theorem to help us with it. So first, I need to get it equal to 0. So I get x cubed minus x squared plus 2x minus 2 equals 0. And then I'm going to try to factor this. So when I group the first two, I could pull out an x squared. I get x minus 1. When I group the second 2, I could pull out a 2, And I also get x minus 1. That's wonderful, because now I can pull the x minus 1 out of both terms, and I would get an x squared plus 2 from the leftover parts. And this is my 4-term polynomial in completely factored form. So now I'm going to set each of those equal to 0. X minus 1 equals 0, and x squared plus 2 equals to 0. So here I get x equals 1. That is 1 real root. And then over here I get x squared equals negative 2. I take the square root of both sides, and I get x equals plus or minus, the square root of negative 1 is I, and the square root of 2 is simplified, so I just get plus or minus I square root of 2. This is 2 non-real roots. Remember, your non-real roots always come in pairs because of the plus minus. So this is 1, 2, 3 roots for my 3rd degree polynomial. Problem 9 is pretty much identical to this one. So let's take a look at problem 10. In problem 10, or something like problem 10, it's really important to remember your GCF. So if I pull out an x from each of these, I would get x to the 4th plus 2x squared minus 15. This is what we call quadratic style. It's completely different than the quadratic formula. So quadratic style simply means I have an x to the 4th, an x squared, and a constant. I can factor this with the diamond method. So in this case, I can look at this guy as, now I'm getting ready to factor inside here. This would be something I want it to multiply to negative 15 while adding to a positive 2. So I'm thinking 5 and 3, and I would need the 5 to be positive in order to add them to get 2, but then to multiply them and get negative 15. Because my coefficient is 1, I do not need to do factor by grouping. I can just bring the 5 and the negative 3 over inside my parentheses. However, it's a little bit tricky because this was an x to the 4th and an x squared. So in my parentheses, I would have my x squareds. I bring over my plus 5, I bring over my minus 3, and then I double check my work. X squared times x squared is x to the 4th. 5x squared minus 3x squared is indeed positive 2x squared, and 5 times negative 3 is negative 15. Everything checks out. So now I can set each of my terms equal to 0. X equals 0, x squared plus 5 equals 0, x squared minus 3 equals 0. So now I do my math. The first one's done. This is my 1 real root right here. X squared equals negative 5. Take the square root of both sides. X equals plus or minus, pull out my I, square root of 5. This is 2 non-real roots. And then x squared